4.6 billion years ago, a blue-green ball we now call home was formed. Its structures took years to form to give us what other planets cannot: life. As time passes by, we are living sustainably, with the Earth providing us everything we need to survive. But due to the advancement of technology, population skyrocketed that our planet cannot anymore provide the sufficient amounts of resources for us to continue achieving sustainability. These resources, specifically the non-renewable minerals, are on its depletion rate, which, if not given action, could result to a major impact on the environment, including us. In addition, volcanic eruptions, earthquakes, and tsunamis seem to happen often nowadays, continuously causing disaster to mankind. Is this a sign for us to stop for a while and give time to study our planet? Will this serve as an awakening for us to take actions regarding the depletion of resources? Will we still be able to help our planet just as our planet have helped us? To learn more about the Earth, we must go far.
Everybody, well, don't you know it's me now?
Good morning, student. Welcome to our Earth Museum.
Who are you?
I will be your guide throughout this tour. I've heard you complaining about your assignment, and I would love to help you out. So your topic is about geology, huh?
Geology?
Geology is derived from the term geo, which means earth, and logos means study. So geology is a science devoted to the study of the dynamic process taking place on the Earth's surface and its interior.
Oh, yeah, that's our next lesson.
The Earth's structure is divided into three major concentric zones: the crust, the mantle, and the core. The crust is the outermost layer of the Earth, considered to be the thinnest zone, having only a thickness of 50 kilometers. It consists of two types: the continental crust, which underlies the continents, and the oceanic crust, where ocean basins lie and make up 71% of the Earth's crust. Underneath the crust is the mantle. It is the thickest zone in the Earth's structure, with 2,900 kilometers and mostly consisting of solid rock. Its temperature varies as it gets near the core, reaching up to 4,000 degrees Celsius. This layer contains the lithosphere, a combination of the crust and its rigid outermost part, and the asthenosphere, which is a zone of hot, partly melted rock that floats. The last zone is the core, the Earth's innermost zone. It is divided into two parts, the outer and the inner core. The outer core is the only liquid layer of the Earth, which contains iron and nickel. It is 2,200 kilometers thick, with a temperature of about 5,000 degrees Celsius. The 1,250 kilometer thick inner core, meanwhile, is in its solid state due to the tremendous pressure produced by its rocks. It is the hottest zone with a temperature of 6,000 degrees Celsius.
That's all? It's quite easy, huh?
This way, please.
Whoa! What's that?
I think we're now here at the geologic processes section.
Won't this stop?
The term geological processes refers to the forces that shape the planet physically. It ranges from volcanic eruptions, earthquakes, and tsunamis, which cannot be prevented by humans. Volcanic eruptions happen when lava and gas are discharged from a volcanic vent. Although it has some benefits, most of the time it causes harm to the living organisms around it. As a volcanic eruption is an example of external process, one example of internal geologic process would be earthquakes. It occurs mostly at the boundaries of tectonic plates, when colliding plates create tremendous pressures in the Earth's crust. The place where an earthquake begins is called the focus. The earthquake's epicenter is located on the Earth's surface directly above the focus. Its severity is measured by the magnitude of its seismic waves using a seismograph and a Richter scale. Earthquakes may cause tsunamis. A tsunami is a series of large waves generated when part of the ocean floor suddenly rises or drops. Minerals are part of a person's daily living. From the salt that we put in our food, the lead that we sharpen in our pencils, the vehicles we ride, to the buildings being constructed. Minerals are involved. But then, what is a mineral? Mineral is an element or inorganic compound that occurs naturally in the Earth's crust. There are over 2,000 varieties of minerals here on Earth, which comes in different shapes, sizes, colors, texture, and more. In order for a substance to be a mineral, it must meet the following requirements that geologists are using. First, it must be natural occurring. A substance must be proved to produce naturally, thus not made by people. Second, it has to be inorganic. It must not be made out of living things.
Third, solid. It must not be a liquid or gas at standard temperature and pressure. Fourth, it must have a definite chemical composition. A substance must obtain the same chemical formula no matter how many times it is produced. Fifth, the atoms that make up the substance must be arranged in an orderly structure.
Now that you have a preview of minerals, let us take a closer look at a solid mass formed by a combination of one or more minerals, the rock. Rocks have been part of our everyday lives. People in the ancient times used rocks as weapons and tools for hunting, thus the Stone Age. Even the Earth's lithosphere is made of rock. Like minerals, rocks can also come in variation. It has three different types: the igneous rock, the sedimentary rock, and the metamorphic rock. Let us differentiate these three using the rock cycle. Beneath the Earth's surface is a mixture of molten rock and solids called magma. When this cools, it makes crystals and forms igneous rock. When the magma solidifies underground, it is called an intrusive igneous rock. Example of this is a granite. However, when it is formed above the ground, such as a pumice, it is called an extrusive igneous rock. On Earth's surface, wind and water can break rock into pieces. They can also carry rock pieces to another place. Usually, the rock pieces, called sediments, drop from the wind or water to make a layer. The layer can be buried under other layers of sediments. After a long time, the sediments can be cemented together to make sedimentary rock. In this way, igneous rock can become sedimentary rock. A great example of this is limestone, which is now used in many constructions as floor tiles and windowsills. When rocks get buried further, accompanied by enough heat and pressure, metamorphic rocks, such as marble and gneiss, are formed. But under extreme temperature and pressure, these metamorphic rocks become magma, its first state in the process. This cycle repeats and never stops. Mineral resource is a concentration of naturally occurring material from the Earth's crust that we can extract and process into raw materials and useful products at an affordable cost. There are two types, metallic and non-metallic. Ore is a rock that contains a large enough concentration of a particular mineral, often a metal, to make it more profitable for mining and processing. A high-grade ore contains large concentration of desired mineral, while a low-grade ore is only considered as such because it has smaller concentration of mineral in question. The more accessible and higher-grade ores are usually exploited first. As they are depleted, mining lower-grade ores takes more money, energy, water, and other materials. It also increases land disruption, mining waste, and pollution. Surface mining is a process where materials lying over a deposit are removed to expose the resource for processing. It depends on two factors: the resource being sought and the nature of the land lying over the resource. Overburden is a process where soil and rock overlying a useful mineral deposits are removed. It is usually deposited in piles of waste material called spoils. Strip mining, open pit mining, and mountaintop removal are under the category of surface mining. There are two types of strip mining: the area strip mining and the contour strip mining. The area strip mining is used where the terrain is fairly flat. A gigantic earth mover strips away the overburden, and a power shovel removes the mineral deposit. Contour strip mining is used mostly to mine coal on hilly or mountainous terrain. Earth movers remove the overburden, An excavator or power shovel extracts the coal, and the overburden from each new terrace is dumped onto the one below. Mountaintop removal is where the top of the mountain is removed to expose seams of coal, which are then extracted. And the opposite of surface mining is subsurface mining or underground mining. The underground mineral resources are removed through tunnels and shafts. This method is used to remove coal and metal ores that are too deep to be extracted by surface mining. Mineral resources are distributed unevenly among countries. Massive exports can deplete the supply of a country's non-renewable minerals. The future supply of any non-renewable mineral depends on two factors. First, the actual or potential supply of the mineral, and second, the rate at which we use it. We have never completely run out of any mineral, but the mineral becomes economically depleted. There are 5 choices. Recycle existing supplies, waste less, use less, find a substitute, or do without.
Hey, are you still there?